Hey guys, so we're just going to continue with our video on building our Tesla valuation model using a cross-sectional regression. And so just in our last video, we were pulling our information or data from FinViz. We had our variables here, and we just wanted to find the relationship between earnings yield and some of the variables that we hypothesize has a strong relationship with that. And so we looked at gross margin, operating margin, profit margin, earnings per share, and volatility. We then specified the industry that we are interested in and looked at specific companies within that industry, specifically the auto industry. And then further, we're going to go look at the technology industry and see if, depending on the industry, what variables drive earnings yield. Depending on what industry, is there a difference between the value of the auto industry and how you value Tesla versus the technology industry and the variables in there and how you value Tesla. So again, I'm just gonna paste in here the variables that we're interested in. So if we look at our auto DF data frame here, we can see this is the data frame we're going to be working with. We have our earnings yield, sales growth, gross margin, operating margin, profit margin, return on equity, earnings per share growth, and volatility. And we have all the companies within, or some of the companies within the auto sector. So now what we need to do is we usually, before we build a model, we want to look at the specific relationships of each of these variables with earnings yield in this example. So we're going to do some good old-fashioned scatter plots. So to do that, we're going to import matplotlib.pyplot as PLT. And we're going to just say plt.scatter. And we're going to look at our auto data frame. We're going to look at the sales growth and auto data frame and earnings yield. That will be our Y variable. So let's plot that. So there we go. We can see it doesn't look like a very strong relationship here. So let's look at our next variable. Let's look at, what is that, gross margin. Gross margin. Again, maybe there might be a linear relationship here, but there looks to be an outlier. This could be an outlier here. Let's continue. I'm just going to copy this. So let's look at operating margin. Now there looks like to be a relationship here, though unfortunately there may be some heteroscedasticity. What does that mean is as the x variable gets larger and larger, the variance gets larger as these variables change. So you can see here the variance is not so. If you were to create a line of best fit, you would see the variation around that line of best fit would get larger and larger. So that's usually not the best type of data that we want to put into our model, and we're going to have to fix that. Specifically, the reason why is because we can't trust our model. The t-statistics from it will be biased and unreliable. So let's continue. Let's move forward. So we did operating margin. Let's look at profit margin. So profit margin again looks like some type of relationship, but again this increasing variance. So that was profit margin. Let's look at earnings per share growth. Doesn't look like a very strong relationship here. And then lastly, let's look at volatility. Now this looks like a much stronger relationship. The variance looks like there's some constant variance across the variables, and there looks to be an inverse relationship, a negative relationship here, linear relationship. So now that we have an idea of some of the variables and their relationships, we can begin to actually build our model. And it looks like, oh, we forgot return on equity here. Let's throw an ROE here. See if we got a relationship here. It's okay. Again, this could be an outlier. So I like the volatility. We're going to start with that first in building our model. And so to do that, before we do that, we need to let's look at our data frame. And we need to remove Tesla from this data frame and separate it. So to do that, I'm going to say Tesla is equal to auto data frame. And we're going to look at specifically the ticker column, and if that is equal to Tesla. So now we have Tesla separated, but we still need to modify our original data frame. So to do that, I'm going to take the same code here, but instead of equals, I'm going to say not equals. So this is going to remove Tesla out of this data frame. So there you go. As you can see, we moved Tesla. So now we have the data frame that we're going to be working with here. And now I can use something called stats models, which is going to help us build our model. So we're going to say import stats models. It's just a library that we're going to be using, statsmodels.api as SM. And we're going to import Patsy, which is going to help us organize our data. So from Patsy, import D matrices. And we're going to say import numpy as NP. I think we might need that later. So to use D matrices, we're going to say is Y, our dependent and independent variable X, is just equal to D matrices. And we're going to look at, since we liked the volatility, we're going to look at the earnings yield and volatility. I'm going to say data is equal to our auto data frame. And our return type, that will be equal to data frame. And so what this has done for us is created our Y variables and our X variables and added an intercept. So now we can build our model. So we're going to say model is equal to SM for stats models dot OLS. We're going to use an ordinary least squares model, and then we're just going to put our Y variable and our X variable in there. So run that. And now we just need to fit our model. So we're going to say results is just equal to model.fit. And now we can just print out the results of our model and summarize it. Results.summary. And equals 13. And so you notice that we have a R squared, 8.87. That's pretty high. But what's more important here is our coefficients. Our coefficients are T statistics, which is very high and significant, and our p-value is basically 0. So you'll notice here that we have a negative coefficient, so there's an inverse relationship. So what is that saying is that as there's higher, greater levels of volatility, there's a lower earnings yield. So we would predict that if for any given volatility for any type of security, at least in the auto sector, the higher the volatility, the lower the earnings yield. And so, and remember, we use the volatility as our proxy of risk. So given that, we can just look at our results.params. So that's just going to take our coefficients out of here. And we're just going to build out our simple cross-sectional regression model. So remember, you learned this in the 5th grade. It's just results.params. And that's going to be 0.22. That's going to be our intercept. We're going to add that to our results.params. That's going to be our beta. And we're going to multiply that by our Tesla. And remember earlier, let me just print that out again. It's going to see Tesla volatility. So we're going to say Tesla vol, which is 0.083. Print that out. So basically our model is predicting that the earnings yield should be negative 0.200435 versus the market's earnings yield of negative 0.006724. So in our next video, we're going to talk about how to interpret these results, and then we're going to add more variables to our model and see if there's any relationship there. And finally, we're going to look at the technology sector and see if using those relationships, does that equate to a different value or earnings yield for Tesla. So if you like this video, please subscribe. Till next time, guys. Thank you.